So as you can see, our speakers already joined us, and we are ready for our first session of day 3, where a lot of open discovery platforms and projects of Ivy Plus libraries will be spoken about. Especially the case study of Stanford University is something that our speaker will focus on. As has been the case throughout the workshop, we are lucky to be joined by speakers who are extremely cued into library technologies and their domains of work. Tom Cramer is no different. He's Stanford's Associate University Librarian and the Director of Digital Library Systems and Services, as well as Chief Technology Strategist. He is the architect and originator of the International Image Interoperability Framework and a leading figure in the development, deployment, and the use of numerous digital library applications. He also directs the Stanford Digital Repository, the development of SearchWorks, and the library's technical approach to its linked data infrastructure. So without further ado, I will hand it over to Tom and allow him to take you through his presentation. I urge all the participants to have questions ready now and also throughout the session as and when you have them. You can ask them verbally or you can put them on chat so that we can take them up after the session. Over to you, Tom.
All right, thank you so much.
I'm going to stop sharing. So. Yeah.
All right, now I'll start sharing. And, oops, I always do that. Share and present look very similar. Oh, happy Wednesday, everyone. I'm really pleased to join you today. I hope you're having good weather. I can't tell what our weather is like today because it's still dark outside. It's about 4 a.m., 4:30 a.m. Here in California. We would say sunny California, but I don't know if the sun's going to come up. I am really pleased to bring this case study of digital library innovation to you today. This is a collaboration that we called POD, for Platform for Open Discovery. And as we talk through it today, I think there's some interesting opportunities and maybe some lessons around digital library technology and digital library services. But I think there's also an opportunity for learning to look at how collaboration can be born, what's possible to do when the marketplace is insufficient to meet a set of needs, and how libraries can work together to provide their own capacity and their own services in the face of a vacuum otherwise. Let's see here, advance. Okay. So one of the first things, see a strange red arrow. Aha, someone's drawing on the screen. Which I'm not going to monkey with because thank you for the volunteer highlighting. So you may be familiar in the United States with the Ivy Plus. So these are the 8 traditional Ivy League schools in the East Coast. So Harvard, Yale, Princeton, Dartmouth, Columbia, Cornell, Penn, and I've forgotten one. And so these are traditionally, they're private schools, highly selective, research-intensive universities. And they're joined by an additional 5 institutions that aren't as old or in the East Coast, but are also very selective, research-intensive, and private. And so that includes Stanford University, University of Chicago, Duke, MIT, and Johns Hopkins. These institutions, because of their similarities in academic community, their selectivity, and their library collections, have both banded together not just as an athletic environment. If you could mute, that would be great. Thank you. Have banded together not just as an athletic league in the Ivy's case, but also as an academic league. And one of the areas where they collaborate is around library services. And this is the Ivy Plus Libraries Confederation. Together, all 13 institutions hold more than 90 million individual titles that are lendable. And they have developed, we have developed an interlibrary loan program known as Borrow Direct, which provides extremely high value and deeply appreciated access to one another's collections. So imagine being at Harvard with 15 million volumes at your disposal, or Yale or Stanford or Columbia with 10 million volumes at your disposal. The ability to actually consult, borrow, and read from 90 million books, even with those tremendous library collections, 90 million is way more than 15 million, 10 million, or 5 million. So it's really a power of, it's an excellent illustration of the power of collective collecting and cooperative library services. You can see more about the Ivy Plus libraries if you're interested at the URL on the screen, ivypluslibraries.org, and it works with or without the Y. Borrow Direct has been described as interlibrary loan on steroids. So not only is there a massive collection from which you can request loans from other participating libraries, the collections are massive and deep. There's also extremely rapid turnaround time for most of the members of the Confederation. If you may be familiar with East Coast geography, most of the Ivy League schools are quite close to each other. They're only a couple of hours worth of travel time. And courier services have been established over the years that allow for extremely rapid turnaround. Most requests actually happen within 2 days, depending on the location of the institution and the borrowed item. Some are fulfilled within 3 days. Stanford, which is way over on the other side of the country from the other institutions, we have slightly longer turnaround times, usually 3 to 4 days by the time an item is picked, delivered, and then picked up at the reciprocal library. There are more than 3 million loans per year to our collective patron base, which is in the low hundreds of thousands of students across all the institutions. And as I mentioned, it's extremely popular and well received. I'm going to see, okay, I'm going to erase our drawings and we can continue without the extra decoration. Now I need to stop annotation, there we go. In the histogram on the left, you can get a sense for the tens of thousands of items that are either borrowed or received. Actually, in this case, they're just lent from each of the participating institutions. There's a problem, though, which has developed over the years. As good as Borrow Direct is, discovery for Borrow Direct, that is to say, what are the items that I can borrow from other institutions that might not be held at my own, is a fundamental challenge. And the issue is essentially this first bullet is that patrons cannot see the items held at other libraries by searching in their own catalog. So if I'm at Stanford, I can see everything that Stanford holds, but if Stanford doesn't hold something that might be at Harvard, Yale, or Princeton, how am I to know that that is there? And where should I search? Right now, the practice is, because many of our patrons are expert researchers.
I'm so sorry about this, Tom. Can I please request all participants to be very careful and just keep yourselves on mute when you join?
Thank you. That's much easier. Patrons don't know what's available at other libraries unless they go and search the catalogs of the other libraries. So in some cases, if you're an expert researcher and you know the collections in your field for 10, 20, 30 years, you already know what's held at other libraries. But oftentimes you're unaware because you're researching in a new domain, or perhaps you're a graduate student or even an undergraduate student looking for a rare item or one beyond your library's holdings. The Borrow Direct does have a union catalog interface, but it's not really built on a union catalog. Instead, it's powered by a service known as Z3950. If you're familiar with this technology, it's federated search. And so basically a search is entered into a central server, and then via the Z3950 protocol, that search is broadcast out to the catalogs of the 13 participating institutions, And then it returns results into a single pane. If you are familiar with Z3950, you also know some of its detriments. First of all, it's slow. Searches can take many, many seconds, so sometimes 10, 15, even 20 seconds to return results from all systems. And because they're coming from not a central index, but rather 13 disparate systems with 13 different schemas, there's no support for modern affordances for powerful searching, such as things like faceting or advanced search, or the ability to combine records that are logically linked. So if 13 of the institutions held the exact same item with the exact same ISBN number, you'd find 13 different results, very different than you'd find if looking in the catalog of a single institution, where you'd find one result with 13 different items or copies to borrow. We've looked at, in looking at this discovery challenge for Borrow Direct and interlibrary loan, we really have looked at the marketplace. And what we found is that vendor systems are insufficient. They're generally using outmoded technology, and this is the case with the fulfillment service that we're using at Ivy Plus, which is a service called Relay. And when we've talked to vendors about doing a custom solution, they've come at considerable cost and with proposals to basically establish a closed solution or a closed system, something that would meet that exact purpose, but nothing beyond that would be quite expensive to build and to maintain. As we were circulating quotes, we found we were getting costs to meet this challenge in the millions of dollars. So approaching $3 million for development and then ongoing support. That's quite a lot of money, even for very well-resourced institutions for a very valuable service. So the question that we're facing is, how can you enhance discovery for interlibrary loan? And several years ago, we came to the conceptual conclusion is that really what we need is a shared index of our combined holdings, which means contributing records from many different institutions, putting that into a common index to be searched all together, with bringing the benefits of things like faceting, record roll-up, and record normalization, and then also being available to high performance and quick queries. But discovery wasn't the only need that the Ivy Plus libraries have for combining their data. There are lots of collaborative initiatives where we are interested and are actively currently working with each other. That includes projects around collection analysis to feed collaborative collection development. If Stanford is quite strong in collections on Korean history, for example, but not so strong in collections on Japanese history or Japanese literature, but Princeton is, it's helpful to know that, our strengths relative to Princeton, so the libraries can establish basically reciprocal collection development and lending agreements. There are also multiple projects and continuous questions coming up around print holdings and shared print facilities. How many paper copies still exist of this item across the collective to make sure that if we don't hold 13, which is redundant, we at least hold 2 or 3 for the sake of preservation and physical access. There are also a number of interesting projects around the exchange of special collections, both metadata and access about intelligence about our holdings, but then also digital access and virtual reading room access. Those can only be powered by actually knowing what's held at the different institutions. And then finally, there are interesting collections or interesting questions that we're pursuing in terms of transaction and usage data. What's being checked out? What's being circulated the most? What is total acquisition cost look like? Questions like that, so that go beyond bibliographic data and really get to how the library is used. Now, in each individual case, exchanging data is not hard technically, but it is still quite expensive. And the expenses really come around arranging the coordination of identifying what data needs to be exchanged to address these questions. How do you normalize that data? Each institution holds it in slightly different formats and slightly different systems. And then how do you affect the technical exchange? Where is it being gathered? Who is doing the analysis? How do reports get generated? And what we were finding is that while Ivy Plus had been working together over the years, the startup cost for addressing these coordination challenges was so great that there really have only been a couple of successful instances where data has been exchanged in a low friction way. In addition to the questions of coordination, we have that around technical. So while it's not necessarily hard to exchange data, you still have to do it. You have to establish a method of exchange. So that could be FTP file transfer. It could be Z3950 queries. It could be through full file dumps or API-based queries. You have to have some regular basis and frequency for data refresh, the ability to control for changes in the data, both new data, but also edits or deletions. And because everyone manages their data in slightly different ways, there is the question of normalization. The big issues really come around policy and governance. So knowing what data we have and what data can be shared, which needs to be private to the institution, which can't be shared because it's been licensed from a third-party provider and contracts forbid it, and understanding how that data can be shared so it's used appropriately and not misused. And then finally, there is, even though it is straightforward to exchange data, when you start to add up staff time and vendor time, it can become quite expensive. So we're in a situation where we have a definite need for data exchange for interlibrary loan, but we know that's not the only need we have. So within Ivy Plus, we began to consider, well, do we want to solve the discovery problem, or do we want to solve the data problem? And POD developed because there was common recognition from 6 of the institutions that our real challenge was a data challenge, not just discovery. And that's where POD was born. So the mission of this project is to create a platform, not an individual service, not an individual system, not a one-off solution, but a platform that looks at data reuse and service integration as strategic assets for the Ivy Plus libraries. Our plan is to address through open and iterative development these different needs for data sharing, and to leverage the investment in our library's internal capacities rather than investing in external vendors. Through this open iterative process of exchanging data, understanding our needs, and applying that shared data, we would meet multiple library needs and allow innovation in ways that we can anticipate but cannot yet predict the exact form. That is, if we have large data pools together or a data backbone connecting each of our institutions, imagine what we'll be able to create in the future without the high startup costs of coordination, policy, governance, technical exchange, and cost. So this is our mission statement. I'm still quite happy with it. We look back at it as a good mission statement should be and say, oh yes, that's what we're trying to do. So translating that mission statement, basically, in other words, we're looking to do these 7 things. We want to gather data from Ivy Plus institutions. We want to pool that data for easy reuse. We want to enrich the aggregated data as is necessary, doing things like normalization, but also additions to it from various data services, internal as well as external. And then we want to deploy that data to support different needs. An example of a need would be discovery for interlibrary loan. In addition to those 4 key functions, we're really thinking about how we go about doing this and what the intangible benefits are. So we think by building this data backbone and this data lake, actually, we're going to be enabling innovation for the future by reducing the friction and the startup costs of exchanging data. We want to do this in a capacity. So these data projects within IPLC are actually something that we can do on an as-needed basis rather than taking such tremendous investment of time and capital to start up. And finally, we want to recognize as libraries, we think of knowledge as reusable assets. It's not one instance of knowledge for use by one person. A book can be used for many different people, by many different people to satisfy many different questions. data is the same thing. Data is a reusable asset, and we should treat it like, as a knowledge organization, we should treat it as such within the libraries. So instead of spitting out data for individual uses, we actually want to begin pooling it, aggregating it, and being able to leverage it. This is, I think, this is a surprising realization, I think, for most of the libraries within Ivy Plus, and I think also for most of the libraries within that I'm familiar with. They think of assets as something that's external to the organization, something you curate, you build a collection, you steward, but we're not used to thinking about our own data and our own systems as something that we can build off. I think that's one of the breakthroughs for us that are participating in this project. As I mentioned, we don't think that this is just a way to address the discovery issue. So resource sharing or interlibrary loan, this will definitely help. And that's the first use case that's driving our development. But the other use cases, some already in hand, some a little bit more futuristic or perspective, include collections analysis, active work within each of our institutions on transforming traditional data to linked data, which you'll hear more about during this workshop, and also sharing and interlinking our data. We're interested in questions around data mining, things about not only our bibliographic records, but our transactional records, and then futuristic applications such as artificial intelligence. The ability to apply artificial intelligence against 90 million records is not readily available in today's work. It would take tremendous effort to assemble a data set and normalize it. And working with a pool of 90 million records held across 13 million institutions, or 13 institutions, is extraordinarily more powerful than trying to do that over any single institution's holdings. So where are we? I've been talking about the need. In 2019, the libraries came together. 6 of the libraries came together, and that number has now expanded to actually 9 or 10, to decide that we wanted to tackle this in a lightweight way, to see through this open iterative approach if we could come up with a viable way to exchange data using POD as a platform. What we found is, so far through this lightweight collaboration, which I'll describe a little more, we've assembled 75 million records from 10 sources. We have a proof of concept Blacklight environment, which is an open source cataloging application, which proves the approach, pulling all those together into one institution's system, indexing it, and presenting it through a catalog. We've built consensus requirements for how the data feeds will work and what the interaction will be at each of the participating institutions as patrons make interlibrary loan requests and as they're fulfilled. So what's actually the human experience? How do they flow from the catalog to finding an item to requesting it? How does that request flow through interlibrary loan fulfillment systems? And then what are the messages that the patron receive as well as the back office? There's a surprising amount of variability in how our different libraries approach this, even while we're using the same principal systems and the same principal approaches of ILL. Getting agreement on this actually was took several months of analysis and intensive discussions. Finally, we've begun to, while we're starting with interlibrary loan and discovery, we are beginning to look at applying data collected through POD to collections analysis. And the big key here is the technical underpinnings for this is building a data lake for aggregating and syndicating data feeds from each of the participating institutions. This is a work in progress, and I'll have some screenshots to show how far we've come. As I mentioned, just in terms of time frame, this started in fall of 2019. In January of 2020, our colleagues at Penn Library established the proof of concept Blacklight environment. And then, let's see, the pandemic hit just as we were about to intensify operations. So we shifted gears and instead focused on some of the analytic discussions via things like Zoom calls. last fall, we had an intensive development sprint that was multi-institutional with engineers from Stanford and Brown doing development on the data lake. And now we're currently in a period of validation and analysis of the data lake, bringing data in from each of the participating institutions to know that they can provide data feeds to the data lake, as well as 3 test environments where we're consuming data from the lake to make sure that it's fit for purpose. I'll describe all of this more in a second. The project participants so far are now these 10 institutions. Yale University recently joined, expanding our group from 9 to 10, and they're providing their data. So one thing you'll recognize some of these institutions at least. I think Stanford is on this list. One of the interesting things that I think is compelling here is that when we started off with POD, there was a real disagreement about technical direction and approach to take within Ivy+. All 13 institutions couldn't come to an agreement on a single way. And so these 6 institutions listed on the top really formed the nucleus of the collaboration. And we effectively said, let's work together. We believe in this approach. We believe in working with each other. 6 is a manageable number of institutions and collaborators to work with. And basically, we started meeting on a regular basis to do the analysis, the coordination, the thought work, and some implementation to prove the point. Over the last year and now year and a half, what we've seen is the other libraries who were unsure at first said, that approach looks good. I understand what you're doing. And the way we architected the project, it was easy for them to climb on board, either by contributing their data, joining our technical calls, which have been modeled in the same way as an open source project, and or agreeing to a data providers agreement, which I'll talk a little bit about later. So a lesson here was start small and then build to scale and build to expand. And that's what we've done. Conceptually, the way POD works, there are really 5 stages. 1, each institution, and in this case, we have ideally we'll end up with 13 contributing institutions, will publish their own data. So that means coming up with MARC binary data or MARC XML data from their ILS and exporting that as a regular job. The second step is to be able to aggregate that data into something called a data lake, which I'll talk more about. So basically, a data lake can take data from many different sources. And if you're familiar with big data approaches or big data systems, the goal is really to gather the data in and not, once you have the data, you can then go on to the next step, which is really refining the data. So while MARC is an international standard, people use it in different ways. There are not only local notes fields, but people have co-opted some of the standard fields to convey information that makes sense in their local ILS and their local context. But we've also found that people enrich their data and do different types of encoding over time. All of that can be key to actually normalizing the data to a point where it's fit for purpose for interlibrary discovery. The next step is, once the data has been refined in a data lake, is to operationalize it. In this case, what we've decided to do, because our first use case is interlibrary loan discovery, what we want to do is spit back enriched sets of MARC records to consuming libraries. So in this case, Stanford would be contributing its MARC feeds along with those of the other libraries. And as we operationalize it, Stanford would bring back MARC records from all of the other institutions, except for Stanford's. We already have our records, so we don't need them. So what we'll be looking to do is consume the 10 to 13 additional MARC record sets coming from the other institutions so we can index them in our local discovery environment, our catalog, which is called SearchWorks. And then finally, that's the final step. So that after we get the payload of records, we will have a set of 13 MARC records ready to be put through our indexing pipeline and presented through our web catalog. The same thing at Duke, though they're getting all the records except Duke's, the same thing at Princeton, the same thing at Harvard and Yale. So again, that's export the records in the published data set, pool in a data lake, do the enrichment to enable local indexing, load those into Solar, our open source indexing technology, used actually by all 13 institutions. And then for Stanford, exposed via Blacklight. Other institutions are using different systems. University of Chicago uses Viewfind, Harvard and Dartmouth use Primo. So the beauty of this system is people don't have to use a common discovery system. There's variability both on the inputs around publishing data and also the outputs on how you're going to expose the data. And the commonality is this data backbone. Looking at the schematic a little bit exploded, we have each of the institutions are contributing their individual MARC files. We are gathering data actually in a series of data lakes. So the first place where we're storing data is called an upper lake, and that's where data is being pulled in from each of the contributing institutions, and it's also being versioned. So as changes are coming in, we're taking stock of those changes. We're taking periodic updates, and we're also taking periodic full dumps of MARC record loads if people want to completely replace everything that's been added. That data then is normalized as needed. I've mentioned that people do different things with their MARC records, and sometimes transformation is needed. In some cases, that includes things like unwrapping things from MARC XML or transcoding from MARC binary to a normalized form. The goal for this middle lake is to have all of the data that's necessary to export for local indexing. In the future, we're also, because of our early work on collections analysis, we know that our colleagues in collection development have actually very sophisticated queries that they would like to run, which requires full MARC that's been optimized to run specific queries. How many items of this are there in the collection, doing things like deduplication, and then also usage. And then we expect not only for pod exporting data for local indexing, we're also thinking about exporting things into data warehousing or analytic tools, such as Tableau for visualization, slicing and dicing for other purposes like collections analysis, or linked data, or a data mining environment. So I had mentioned a data lake before, and I think this is one of the conceptual breakthroughs that really helped the pod libraries try to understand how do we go from a one-off solution for ILL discovery versus a different one-off solution for collections analysis versus a different one-off solution for linked data into one common data backbone. And the idea behind a data lake is you take any data that you can get and you worry about refining it and deploying it after you get it. This is very different than a data warehouse. If you're familiar with this technology, data warehouses are highly normalized where they're bringing data in from multiple sources, and they're typically they're optimized to support specific queries around business intelligence. So what was our inventory for today? How much money did we spend on XYZ general ledger code? They're quite common within the world of finance and the world of inventory and logistics. This big data approach of a data lake allows you to bring in data for purposes that you're not even aware how you'll use it yet. And it lets you to push the cost of optimization downstream. So gather all of the data, ingest it, blend it together, transform it, and publish it once you know what the needs are, and then distribute it to multiple sources. And what this has really let us do is say, if we have this data backbone, we can collect the data not only once for interlibrary loan discovery for pod, but in the future, we'll be able to use the exact same data feeds for collections analysis. All we need to do is be very accommodating about what types of data that we take in and be able to take in periodic data updates. So I mentioned that last November and December, a multi-institutional team from Stanford and Brown began development on this. So here are some screenshots of the pod data aggregator. And this is available if you look at if you go to pod.stanford.edu, you'll find at least the login screen. You won't have accounts, but you'll see that there's actually running code. So this is an example of the screen where individual institutions can upload their data. In this case, it's using a GUI. They can actually upload an individual file, or they can provide a URL where we'll do an API-based upload based on a remote query. An important thing here is that we're not expecting people, we wanted to bootstrap the process and provide the ability to do manual data uploads. But in the future, we think this will be completely automated, which is why we've also worked on data transfers and data uploads via scheduled jobs and API. Once the data has been uploaded, an important part of an important activity is to do a profiling of the data. So understanding how different institutions have used their MARC data, what fields are populated, and do validation of those fields. So here's an example of a profile of Stanford's MARC data, identifying how we're dealing with MARC holdings information. This is one of the areas of greatest variability because each ILS manages holding an item's data differently. We're also able to create a histogram or analysis both on an individual institution's basis as well as across the entire collective about what fields are populated and how densely they're populated. So here we can see that 92% of Stanford's records have the 001 field, which I believe is the title, but 0% actually have the 002 field populated. So you get a sense of how different institutions have made use of the schema. This is important for normalization, but also downstream for indexing. We've also done, as people have done different encoding and different treatment of their MARC data locally, we've made an effort to actually capture what are the non-standard fields that people are using and how are they used. All of this is important, again, as we're looking at doing normalization to optimize for local indexing. One of the key things, because it's this principle of exchange and coordination, we don't want to just do one-time file uploads. And when you get up to 13 institutions, it's complicated enough and dynamic enough that it's important to have statistics and data dashboards. Here are two examples of the instrumentation that we put in. We track uploads over time, both for file and the number of records. And then to track the actual number of unique records, total records, when data was last updated, the size of exchange and the files, all of the things that you might expect for keeping track of things. Again, this is not incredibly complicated to do, but imagine having to do this every time you wanted to start up a data exchange project. If you'd like more information on the data lake, or if you'd like access to the code, please feel free to go to either pod.stanford.edu, which I mentioned before. All the code is also open source and available in GitHub. Okay, so that's the back end and actually aggregating the data. And at this point, we've got the tens of millions of records that have aggregated, and the institutions are working on actually providing data feeds. We believe that by the end of this month, we will have data feeds from all but 2 of the institutions that are participating. And those 2 are actually replacing their ILS this summer, cutting over to ALMA. And they're planning to provide data feeds once that project is complete. So what about, that's data provisioning, what about data consumption? This is an example of University of Pennsylvania. Their catalog is called Franklin, and what's showing here is their proof of concept blacklight environment, where they've taken in data not only from Penn's ILS, but an additional 43 million records. So as a partial set, a pod near the very beginning. What they've done, if you can mute, please. What they've done is, in addition to indexing their own data, they've added data from Brown, Cornell, Duke, Harvard, and I think Stanford at the bottom. Here's an example search for David Rittenhouse clock. It's only searching Penn's records, which show 3 results. When they include the partner libraries, the number of results expands up to 11. And you can see where the additional results are. So this is an example of a much more powerful search for interlibrary loan. You don't have to know that Brown, Harvard, and Stanford have the additional copies and go and search in their catalogs. You can actually see those in one common interface. Quite powerful. What is not linked here, if you can, Sunny, could you mute?
Sanjayan, I mean, whoever has host permissions, can you please mute, I think it is Dr. Selakuti Sugandhi's audio.
Yeah, just
Thank you. Thank you, Savitra. Thank you, Sunny.
Yeah.
Okay. I hope this is clear. This is really cool. If you're a discovery nerd, which I am, this takes a very complicated process. It has an elegant user interface and actually follows the trail a user might go through to find additional records. What's not shown here is the request process. And that would be the next step to do. Here's another example, and this is a generic search, not starting at Penn with Franklin, but actually just saying, I want to search the entire collection. Let me show all of the places that this would be available. Whoops. Oh, there we go. Sorry. Let me show all the places where this would be available. And you can get a sense for here about the collective collection of the Ivy Plus libraries. If I was going to approach searching Borrow Direct as a collective rather than as a patron of the individual libraries, this is the interface I might use instead. I think this would actually be quite useful in doing collections analysis. One of the areas that also increases friction that I mentioned early on is the question of policy and governance. So when people ask you for your data, unless it's open data, unless it has a CC0 already applied to it, usually you have to consider, well, what's the nature of this data? Are there any security implications? Are there any privacy implications? Are there any contractual implications? Stanford doesn't even record, much less would it share transaction data on who is checking out who is checking out what items, because we really value patron privacy. So that's an example of data that we would never share. But every time a data project comes up, there's a question of how can we actually get agreement that this data is okay to share? And because libraries are risk averse and don't want to do the wrong thing with the data that they're holding, this is often one of the areas of greatest delay in these data sharing projects. So POD's goal is, again, to enable innovation and reduce drag, reduce the friction of doing sharing. So just as we're coming up with a technical mechanism to share data, we also wanted to come up with a policy mechanism. And because we've been lightweight and iterative, rather than have a very extensive contract that each institution would review and sign, what we've come up is basically with a simple statement of principles and agreement from each of the participating institutions. So what we've come up with is for each of the data providers, they can only share data that can be shared. So if they are holding on to data that cannot be shared, then or if they should not contribute data that they know is private, that they know is secure, that they know couldn't be reused by another library. The second agreement from data providers is that all of the data that they're contributing can and will be viewed and used by all of the other pod participating libraries. And that could be for any purpose: research, testing, development, or deployment to a production service. Third is we encourage each data provider in pod to actually come up with an explicit license not just an agreement that you can use this, but to put a CC0 license or a Creative Commons 0 license on it. There's also a set of agreements for the data consumers. There's an understanding that data in the lake is available to anyone in the partnership. So if the data is there, you can take it and use it. But you also have to understand that not all of the data may be cleared for any and every purpose. So some data is licensed to facilitate discovery, for example, but it might not be able to use for cooperative cataloging. And it will be up to the consumer to make sure that they're clearing with each of the data contributors how they want to use it by contacting the originating library for uses outside the minimum standards. This is really an exciting breakthrough because while technology is often not, technology can be hard to do, but it's straightforward. These policy discussions and policy agreements can literally go on for years and years and often are the main factor inhibiting innovation and new projects. And we think that this entire very lightweight agreement, it all fits onto a single page, I believe, if you follow this link, but it appropriately apportions risk, responsibility, and accountability to all the actors, to each of the participating libraries, to those that are providing data, to those that are consuming data. And I think most importantly, because it's been pre-agreed, the next time someone wants to use that data, they don't have to raise the policy question, governance, and ask for permission from all of the contributing libraries. Just a recap as we're coming to the close here. For the 6 lead institutions, there's been, this is just a snapshot on how all of this has happened. So there have been 6 lead institutions. There's 1 representative from each institution. They're really thinking about program development and have formed a project board. We meet about once a week. And have been doing that for a year, better part, more than a year now. So probably 5% of an FTE. The demo Blacklight environment from University of Pennsylvania took one of their developers 1 month to accomplish, once each of the institutions had provided one-time static file dumps. The data lake development with that I demonstrated with the various screens was done in a period of 6 weeks by a team of 8 from Stanford and from Brown. That could have been done in less time, or that could have been done with fewer staff, but one of the goals that we wanted was for this to be well supported, not an individual developer's pet project, but something that would be understood and supported by teams from multiple institutions. And then finally, since last summer, we've been holding bi-weekly calls of a technical group with 25 participants from 10 different institutions have been calling in to do things like validate the approach for data provisioning, understanding how we would use incremental updates to data feeds, understanding what the specifications for fulfillment might be, understanding what the specifications or what the user experience might be. And so that's another large group of people that have been coordinating in a continuous basis in a very lightweight way. Now for, it will be approaching a year come this summer. So I think the conclusion here is that this is a project in flight. This is a project that we're still building as we go. It's been extraordinarily lightweight and iterative. It was based on the nature of collaboration. A single institution couldn't have done this on their own because they would have already had their own data, and they wouldn't have needed to do this on their own because they would have already had their own data. This is a project that inherently exists in an interinstitutional space. We required a long incubation period to really understand what are we trying to accomplish, what's the best low overhead mechanism for doing this, how can we avoid a capital expenditure of $3 million to get this up and running? If we don't know everything up front, how can we do ongoing analysis and specification in tandem with development? And the approach that we've taken has accomplished this. We've managed to avoid contracting with any individual vendor, whether that was an existing system or an external contracting firm. And so what we've ended up doing is really building our capacity as we've gone between the 6 and now 10 contributing institutions. Each of us understands how to contribute data, how to operate a data lake. None of us had data lakes before this project. And we've really avoided the expensive fees that would have made this effort cost prohibitive. And finally, as we've done this, we've seen great interest within Ivy Plus about how could we use that data backbone and the data lake to actually be a strategic asset. So we've been approached by numerous other initiatives to figure out if we could leverage the same technology and the same approach for collections analysis. It will be the next one that we work on. So it's an exciting way to show that we've achieved, I think so far, we're on track to achieve our mission of both supporting challenge 1, which is how do we do better discovery for interlibrary loan? And 2, how do we reduce the startup cost for any other data project?